All right, welcome to this Q2 Review1 video. This week we're going to be reviewing for your Q1 assessment. Okay, your Q1 assessment is going to comprise these 8 math problems. So read these, think about them, and check them off if you feel like you know how to do them. Okay, as we go through this video, and we're going to spend 3 in-class days reviewing. So the first thing on our list is volume of a cylinder, cone, and sphere. So we're going to write down the volume formulas. Pi r squared h. The volume of a cone is 1/3 pi r squared h. And a volume of a cylinder is 4/3 pi r cubed. We're going to use the pi button for all calculations unless we say that pi, in that case, you can use 3.14. Changes things a little bit, but it works. And if you don't know the diameter, the radius is half. So if I ever give you the diameter, you don't use that in the problem. You use the radius. So, all right, my cylinder. Let's go ahead and look at this. Okay, the radius is 2 centimeters. Okay, that's the distance through the circle. The height is 12, even though this is lying on its side. So we would say that the radius is equal to 2. The height is equal to 12. I plug those into my formula. Pi times 2 squared times 12. If I go ahead and I type this into my calculator, let me find my calculator here. Okay. If I type in pi times 2 squared times 12, I get 150.8. And rounding to 1 decimal place is always good. 150.8. Our unit would be centimeters cubed, or cubic centimeters. All right, number 2, radius of 8 feet, height of 22 feet. So radius equals 8, height equals 22. Those go into my volume formula. So volume equals 1/3 pi times 8 squared times 22. Again, we flip over to our calculator. We type in 1/3 times pi times 8 squared times 22. I get 1,474.5. 1,474.5. My unit is cubic feet, or feet cubed. All right, volume of my sphere. Here we are given the radius of 8.1. So the radius equals 8.1. So into my formula of 4/3 pi times 8.1 cubed. I go back to my calculator. I type this in. 4/3 pi times 8.1 to the 3rd power. 2,226.1. 2,226.1 inches cubed. All right, on to the next page. The next page is all about proportional relationships. So there are 2 problem types here we're going to talk about in proportional relationships. All right, so you're reading a book. Oh, let's talk about proportional relationships as a review. Remember, y equals kx, that's our equation. And k, unit rate, equals y divided by x. Remember, where k is unit rate. Remember, unit rate is per 1. So you're reading 3 pages every 2 minutes in a book. Okay? If it's a proportional relationship, it'll go through the origin 0, 0. Well, if I've read 3 pages in 2 minutes, I would read 6 pages in 4 and 9 pages in 6. My unit rate here, 3 divided by 2, would be 1.5. Okay? So is it proportional? Yes. My K value is 1.5 pages per minute. My equation would be y equals 1.5x. So if I go ahead and I plot this, 2 minutes, 3 pages, 4 minutes, 6 pages, 6 minutes, 9 pages, and then I go ahead and I draw a straight line through the origin, I have my proportional relationship. 0, 0, 2, 3, 4, 6, 6, 9, and so on. All right, water bottles are being produced in a soda plant. Okay, here you go. We have two nice ordered pairs here. Let's go ahead and put those down. We have 2 minutes and 50 bottles of soda. We have 6 minutes and 150 bottles of soda. If I take 50 divided by 2 and 150 divided by 6, those both equal 25. That's my unit rate. So the bottling thing would make 0 bottles in 0 minutes and would make 25 bottles in 1 minute. So is it proportional? Yes. K equals 25 bottles per hour. Nope, not hour. Minute. The equation would be y equals 25x. So if I want to find out how many bottles we've produced in 60 minutes, I would take y equals 25 times 60. Type that in your calculator. It's 1,500 bottles. Okay, on to slope. This is what we've been talking about. Remember, slope is equal to two things. Change in y over change in x. Also, y2 minus y1 over x2 minus x1. So here on number 6, we're finding slope from these graphs. Now, did I give you the exact beautiful dots? No, but you can add them in. Do you notice how those are the two spots that goes through the grid nicely? So now I go from my left point up to my right point over. I count those distances, 3 and 4. Change in y goes on top. So my slope would be 3/4. All right, moving to the side. Again, we don't have pretty points. That's okay. There's one there, and I see one here. Okay, so those are nice looking points that go through the grid well. So we're going to go up. We're going to go over. Now I need to start counting. That's 3 units to the right and 1, 2, 3, 4, 5 units up. The number that goes on top is the change in y, 5/3. All right, here, again, let's look for good points. Okay, so there's a nice point right there. Now, going down along my line, okay, I don't see any good points until I get to right there. Okay, no, oh, I missed one. There's actually one right here. We go down that far, we move over. That's a -2. My arrow is pointing down to the right 2. So we have -2/3 as my slope. All right, my final one. Ooh, look at the scale on this one. Not going up by 1s, going up by 2s. So there's a good ordered pair there and a good ordered pair here. Okay, this is actually very similar to the line above it. But the scale's changed, and that's on purpose, okay? So if we look at this, every box is worth 2. So I've gone up 2, 4, 6, 8, 10. And I've gone to the right, 2, 4, 6. So my slope is 10/6, which is the same as 5/3. Either one of those can be your answer. Let's just give 10/6. All right, slope from a table. Change in y. That's going down 8. Down 8, down 8. If you forget, you subtract up 2, 2. So my slope on this one is -8 divided by 2. -8 divided by 2 is -4 or -4/1. Okay, here you might do some subtraction. Okay, 45 minus 27. Well, that's 18. 63 minus 45 is 18. 81 minus 63 is 18. The change in x is a little obvious. It's 2. So my slope is 18 divided by 2, which is 9. You could give that as 9/1. It doesn't matter. All right. Change in y over change in x. So I'm going to write down my slope equals a fraction. I'm going to highlight my y's. I'm going to highlight my x's. My y's go on top. My x's go on bottom. Remember, we subtract 17 minus 9. Those are the two blues. And then the two reds are 10 minus 7. 17 minus 9 is 8. 10 minus 7 is 3. All right, same thing here. Lots of negatives. Okay, so 3 and negative 4. And then negative 5 and negative 3. You might need your calculator on this. That's okay. If you don't understand how to subtract negative numbers. So let's take the second y. The second blue one would be negative 4 minus 3. The second x would be negative 3 minus negative 5. Okay, negative 4 minus 3 is negative 7. Here, remember, this turns into addition. Okay, two minuses is really addition. So negative 3 plus 5 would be 2. If you didn't understand that, go to your calculator. All right, thank you for listening and following along.